Now we want to look at the idea of adding and subtracting fractions when trig functions are involved. Anytime that we add or subtract fractions, we have to have a lowest common denominator. So we need these to have the same denominator. Right now we have cotangent theta over 1 plus 1 over cotangent theta. The LCD, when I look at those denominators, would be cotangent theta. And we would need to multiply top and the bottom of the first fraction by cotangent theta. And when we do that, we get cotangent squared theta over cotangent theta. And then we're going to add the second fraction to it. Now that they have the same denominator, we can keep the same denominator and combine the two numerators together on top of our new fraction. So that would be cotangent squared theta plus 1 all over cotangent theta. In part B, it's a little bit more interesting because our denominators are not the same, but they look really, really close. So we have to be careful about how we find an LCD when we have two terms and two terms. LCDs. What would be our LCD? Well, the only way that I can actually change a denominator is by multiplying something in. So our actual LCD, when we look at to see what each of these is missing, this one I would have to multiply in a sine alpha plus 1 times the top and the bottom. And this one I would have to multiply top and the bottom by sine alpha minus 1. So we multiply them basically times each other to find that LCD. So our lowest common denominator would be sine alpha plus 1 times sine alpha minus 1. So those two basically similar to the idea of binomials multiplied together. Now our new fractions would be sine alpha plus 1 divided by that LCD. If I were to multiply these two together, let's go ahead and multiply those together. If I was to multiply those two binomials together, we would get a difference of squares. Foiling, so you could FOIL, sine squared alpha minus 1. So let's go ahead and FOIL that together, multiply that, make that look a little bit simpler. So we can FOIL that. Minus, and then top times the top, we get 1 times sine alpha minus 1. Divided by, of course, we multiply these together, get the same denominator, sine squared alpha minus 1. We want to be careful because we are subtracting these two fractions, and this idea will pop up again later on. So you want to be careful that the negative distributes to both terms. So when I combine these fractions together, that's sine alpha plus 1 minus sine alpha, and then plus 1 when I distribute that negative. All over sine squared alpha minus 1. So all over that same denominator. Now we want to combine like terms on top of this new fraction. And when we combine like terms, we have sine alpha minus sine alpha, and those end up canceling each other out. And 1 plus 1 is 2. So we get 2 over sine squared alpha minus 1. And this would be our final result as a simplified fraction. Throughout the rest of this chapter, we will run into times when we need to simplify a complex fraction. So let's recall how we simplify a complex fraction. When we have two fractions where one is being divided by the other, so one fraction divided by one fraction, we keep the first fraction the same, we change from division to multiplication, and we flip the second fraction. So that's keep, change, flip. So this would look like 1 over sine theta times, now we're going to flip the second fraction, so that would be times sine theta divided by cosine theta, and we would like to simplify this as much as we can. Well, when I'm multiplying, we can cancel common factors across the two fractions. If one factor is on top and one factor is on the bottom, they can cancel out. And then when I multiply across, now we get 1 over cosine theta. Now that only works if I do one fraction divided by one fraction. If I have, and if I look at example B, if I have more than one fraction on the top, and here we actually have 3 separate pieces. We have we have sine theta divided by cosine theta, and then we have cosecant theta divided by cosine theta. We actually have 3 separate pieces. On top we don't just have one fraction, we have more than that. So in order to simplify a complex fraction where I have more than one fraction in the top or more than one fraction in the bottom, we will need to multiply by the LCD of all of our fractions. So when we look at all of our fractions, let's think about this as 1 over 1. We have 1, we have cosine theta, and we have cosine theta. So the LCD of all of those little mini fractions would be cosine theta. Once we have our LCD, then we multiply every fraction on the top and the bottom by cosine theta. And you can think about that as like cosine theta over 1, if that helps. Because we now are going to simplify each of those multiplications. So in the first part, we have cosine theta times 1. Well, that's just cosine theta. And in the second part, we have sine theta times divided by cosine theta times cosine over 1. So our cosine trig functions will cancel each other out. We're left with minus sine theta. So now we have what we call a simple fraction. We do not have any little fractions within the larger fraction. And on the bottom we have the same thing. Cosine thetas cancel each other out. We're left with cosecant theta. So now we would have what we would call a simple fraction. Here we have another complex fraction that we would like to simplify and change that to a simple fraction. Since we have more than one fraction on top, we actually have 4 different terms, 2 on the top, 2 on the bottom. So we can't just flip and multiply. We will actually need to multiply by the LCD. So I need to figure out what is the LCD of all of these little fractions. So let's look at all of the denominators. And we have tangent theta and we have 1. So it looks like her LCD would be tangent theta. So we're going to multiply all 4 of these terms on top and the bottom by tangent theta. Tangent theta on all 4. And you can think about that as tangent theta over 1 if that will help. And then we start to simplify each of those multiplications. So the first term, we multiply that by tangent theta. The tangent thetas will cancel out and we're left with 1. So we have 1 times 1 over 1 times 1. So we get 1. So the first term simplifies to just be 1. The second term, nothing cancels out for that multiplication. We just have 1 times tangent theta. So that would be plus tangent theta. The 2 terms on top are reducing, we're getting rid of those fractions that were present. In the bottom left, tangent theta and tangent theta will cancel out. We're left with 1 there again. And on the bottom right, nothing cancels out. We have minus 1 times tangent theta, so that's minus tangent theta. So here we have our simple fraction, and we're simply using the techniques that we learned in algebra, but we're applying them to the ideas of our trig functions.